Hello and welcome to the third and final skill builder from UCB on Computing and ICT Level 3. My name's Edward Bird, I'm the Assistant Dean of the Business School, and so far we've covered an introduction to Python, why use Python as a language, how to set up the development environment, data types such as integers, strings, floats and booleans, and then the operators, which are the arithmetic operators, the math symbols, plus, minus, multiply, divide, the relational operators, greater than, less than, equal to, and the logical operators, and or not. In part 2 we looked at collections and mainly lists, decisions, which were if statements, elif, else statements. So if we want to make a decision, we want the program to make a choice over which commands it executes. And then iterations or loops, and those were for loops and while loops. Today in skill builder number 3 we're going to look at functions, which are extremely useful, and then have a think about how we might start designing larger programs. In the final video I will talk through the programming challenge and introduce that as well. There's a competition. Okay, so today, as I mentioned, functions, and then quick look at how we might design our programs. Before we do that though, what I'd like to do is just go back a week, because I did set a couple of tasks. I asked you to have a go at writing a couple of programs, one which was a program that adds up all the numbers between 1 and 10, and to do that using a for loop and a while loop. Now hopefully you've been able to do it, but as beginning programmers, actually this isn't particularly easy, so I thought it only fair to provide you with an example and to talk you through the solution. Okay, so I'll take it right from line 1 all the way down, and then we'll run the program and see what happens. So from line 1 you can see I've used a sort of triple quotes here, 3 lots of double quotes. And anything between 3 lots of double quotes is a comment. And remember, a comment is ignored by the compiler. So that's just an aid memoir to the coder to remind them what the purpose is of the program. And then we've got a single line comment here, which begins with a hash symbol. And we're going to create a variable to store the total. And then we'll initialize that to 0. So total equals 0. We assign the value 0 to the variable named total. Okay, and the reason we're doing that is we always want to start from 0, and then each time we add a number we'll add it to the total. Then we'll create some variables to indicate the start and end numbers. Well, it says between 1 and 10, so we'll have a starting number equal to 1, and then we'll assign 10 to a variable called the ending number. Now you might notice that these are in capital letters, and the reason for that is these values will not change in the program. They're known as constants. They don't change. The starting number will always be 1, the ending number will always be 10. Okay, and what we're doing here is we're going to be adding numbers between 1 to 10. So we'll start, if you think about it, we'll start off with 0, add 1, which is 1. And then to 1 we'll add 2 to make the new total 3, then we'll add 3 to make the new total 6, and so forth. So we're doing the same thing over and over again, and one of the things that's key to programming is noticing patterns. So there's a pattern there that each time we get the new number and we add it to the total. So you can see here the pattern is total equals the total plus the number. And because it's a repeating statement, we use a loop. So in the first example we'll use a for loop. Okay, so what this means is for I in range starting number to ending number plus 1. So I will start off at 1, the starting number, and it will keep looping around 1, 2, 3, 4, 5 and so forth until it gets to the ending number, or 1 less the ending number plus 1, which is basically 10. Okay, and then each time it will add that number to the total, and then finally we just display the result. The total is equal to, comma, and then we'll display the value that's in the variable total. Okay, so that's the for loop, and then we'll do the same thing, same problem solved by using a while loop. So again, initialize the total, reset it to 0, set I, our increment, our number to equal starting number. And then what this while loop is saying is while I is less than the end number, which is 10, or sorry, less than or equal to here, the end number, each time we'll add total to total will equal total plus I, and then we'll add 1 to I. So we start off with 1, then add 1, 2, 3, 4. It will continue until we get to 11, and then the loop will quit. We'll quit out the loop and then again display the result. So once we've coded that, we can test the program, run it, and it displays for us. As you can see, it displays using for loop, prints the total, which is 55, using the while loop, prints the total, which is 55. Now if I wanted to change this program to say numbers between 1 and 12, all I need to do is just change the end number to 12, run the program again, and it now updates it to add on the extra 11 and 12, so we get 78. So that was that problem. And then the second problem was the factorial, and for those of you that don't know, factorial, so for example 4 factorial equals 1 times 2 times 3 times 4. Oops. Okay. Which is 2 times 3, which is 6, and then 6 times 4 equals 24. So 4 factorial equals 24. Okay. Similar again. It's a repeating pattern. It multiplies each time, repeating, and then it adds 1 and multiplies it by that new value each time. So again, initialize, so set the factorial, i.e. the answer, to 0 to begin with. We need to get the number off the user, and to do that we use this input function. We can tell it's a function because it's got a parenthesis here. So we'll display on the screen, please enter a number, and then the response will be stored in this variable response, and that will be stored as a string, which isn't much use to us because we're dealing with numbers, so we need to convert the string to a number. So we convert response to an integer and then store that in number, and then we get onto the nuts and bolts, which is the for loop. So what we're saying here is, again, loop around a range between 1 and number plus 1, and then if I equals 1, set the factorial to 1, because the 1 factorial equals 1. Yeah, 2 factorial equals 1 times 2. So we start off, when I is 1, to begin with we'll set the value to 1, that's our starting point, and then we go up to 2. So we increase the value of I to go up to 2. This time we skip past the if statement because I is now 2, so it ignores this, and then it will multiply factorial by 2, so it'll be 1 times 2, and then the new factorial will be 2, and so on and so forth. So I will become 3, and then it'll be 2 times 3, I is 4, 6 times 4, and so on and so forth. And then we'll display the result. So I'll run that. So I'll enter the number 5, and it says the factorial of 5 is 120. Now it's important that we test our programs. Let's just run that one again. So factorial of 7, it's saying is 5040. Now I don't know whether that's right or wrong, so I'll just check the answer. Fortunately there's a little app that I found. So it says factorial of 7 equals 5040. So it's calculated the correct answer. Okay, we just want to test another value. We'll test an easy one. So the factorial of 3 should be 6. Yeah, 1 times 2 times 3. Okay. The only other bit of code that I need to discuss with you is just that last line, that last print statement, which is a bit more complicated than a normal print statement. So the first bit's fine. We're displaying the factorial of, in quotes, and then we've got these curly brackets, and these are called placeholders. And what we're going to do is replace what's in the curly brackets with this, whatever's with the number basically formatted. Okay, and then we can join strings together by using the plus symbol. That's a concatenation, so joining two strings, and then our second string is displaying is, and then another placeholder, and then factorial. So it's going to be the factorial of whatever the number is, and then whatever the factorial is calculated as. And you can see that here. Yeah, the factorial of, we typed in 3, and then is, and then we calculated the value 6. Okay, so those are the solutions. Those are the two solutions to the homework problem that I set in the second skill builder. Okay, so we'll move on to functions, and again we're going back to the w3schools.com website, looking at the tutorials on here. So it states a function is a block of code which only runs when it's called. So we can write a function, and if we don't call it, it will never execute, it will never run. You can pass data and information into functions, and they're called parameters. It doesn't have to have parameters, by the way, but you can use parameters. And then the function can do a calculation, and it can return data as a result as well. So if I go back to the slides, it's a bit like this: input, process, output. We can pass data into a function, do a calculation or process it, and then output the result or return some data. Okay, and the syntax, or the way the code looks, is to create a function, use this def, which I think stands for define. So def, and then some name for the function. They've called it my function here, and as I've said a few times now, the way you know it's a function is you've got these parentheses, and don't forget the colon at the end. Okay, and then indentation, so we've tabbed across 3 spaces and 4 spaces, and then in this case we're just printing hello from a function. Okay, and then to call the function, we just simply type in the function name with the brackets at the end. So we'll just run that in the browser, and as you can see, we've called the function here, and it's just displaying the text. Now if I don't call the function, if I comment that code out, okay, and I run it again, what will happen? Not a lot. Yeah, you need to actually call the function for this to execute. Just edit it, run it again. Okay, and it's updated. I can rename the function, I can give it my own name. Okay, and then as long as I rename it here as well when I call it, so it's called this is my function, Okay, so that it will call this function and then execute a print statement. Hopefully. Yeah, there we go. Okay. So we declare the function to begin with using this def keyword, give it a name, and then tell it to do something. And then we execute the function by just calling it using the function's name. Arguments are not what it sounds like. It's not two people having an argument about something. Arguments are just data that's passed into a function. So parameters or data or arguments that can be passed in. And the way we do that is that when we declare or when we define the function, we put a variable name within these parentheses. So this function is expecting a variable called fname, or some data which it'll store in fname, and then it will print the content of that. Okay. So we'll try that one again, and as you can see, we'll change the surname to Smith. Okay, run it again. We'll change one of these names to Dave. Okay. So run it again. Okay. So it calls the function 3 times. Each time passes a different first name into the function and then prints the first name plus Smith. Okay. So as you can see, we write the function once, but we can reuse it over and over again, which is a really useful feature. Now this is a very simple function. It's only got one line of code, but you can imagine that under here there could be 10 or a dozen lines of code that, you know, to create a more complex function. You can have more than one argument passed into the function. So in this case we've got the first and last name. In this example we've got an error and the reason for that is that when we call the function here, we've only passed one parameter and it's expecting two. It's expecting first name and last name, but we've only passed it a first name. So we'll pass it. We'll try passing it two values. This time it works. So Dave, F name equals Dave, L name equals Smith, and then we print Dave Smith. Okay. We can also have an arbitrary number of arguments. So what that means is basically it could be any number of arguments. We don't know, and we just do that just by putting a star in front of the argument. So star kids. It could be one kid, two children, 5 children. We don't know. In the example, they've used 3. Okay, but we could add Fred, Billy, yeah, and let's display kid number 4. So Emil is 0, Tobias 1, Linus 2, Fred is 3, and Billy's 4. So hopefully it will display Billy. Yeah. So using the star symbol is really helpful. We can in just a single variable we can have 1 to 20, 30 variables passed because in this example we don't know how many children there will be. Okay, so that's quite useful. And we can also we can also set using the keywords themselves, the argument names themselves, and we can define default values as well within. So we could say, for example, here L name equals Jones as a default value, and then let's see if this works. So we haven't specified the surname when we oops, missed the S off. So we haven't specified the surname when we called the function. We've just said Dave and left it blank. So it's automatically set L name as Jones. Okay. There's more to it than that, obviously, but that's the basics. That will get you started. You'll be able to create simple functions that can accept parameters. You can have unlimited numbers of parameters. You can have default values, and you'll know how to define a function. Again, don't forget the colon at the end. Don't forget to indent. Starts off with def. Define, give the function a name, some parentheses, and then some statements inside the function. And then to call the function, we just use the function name. Okay, that's functions in a nutshell. And we can use functions to break large programs down into subroutines or subprograms, smaller programs, which makes it much easier to read and makes it much easier to bug fix. So if there are errors, we can find the errors much more quickly. Okay. Next then, I just want to quickly talk about designing structured programs. So as our programs get larger, we need to really think about it and plan them out in advance before we start writing the code. So generally programs are of the format: take some data, input some data, whether it's data typed in, someone pressing something on a screen, or reading some data from a database. Process the data, whether it's doing some additions, multiplications, or sorting data, filtering data, and then display it either to a printer or as a sound or as text on a screen. Okay, and an example here of the this is called an input process output diagram. So we can list the inputs. So this program is used to create a little calculator. So the input is two numbers, input number 1, number 2, and then whether it's an addition, subtraction, multiplication, or divide. The process is to store the data in variables and then to do the calculation, and then the output is to display the results of the calculation. And when we go about planning a program, we first want to capture the requirements. So the question is, what does the user want the program to be able to do? We have to understand first, what do they want it to do? Understand the problem. Second is create a specification and a design. So it could be a user interface. How's the screen going to look? If it's a web page, how does the interface look on the web page? What variables do you need? What's the process flow? Write the code, and then, as before, test the program. Does it get the correct answer? Like the factorial program, does it calculate the right factorial? And to do that, we can, in terms of the processing, we can use flowcharts. And just to show you quickly, this is a really good free website. If you've got a Gmail account or a Facebook account, it's called creately.com, and I can create in this simple flowcharts. There are a number of different computer science diagrams in here, actually, from network diagrams, data flow diagrams, databases, and class diagrams, which we'll come on to later in the course itself. But we're interested in flowcharts today. Okay. With flowcharts, we'd normally start with the terminators, which is the start and the end. Start the program, the end of the program. we'd have some sort of input, which in the calculator question would be something like, you know, so it's get two numbers and the operation, which would be like a plus, minus, multiply or divide. We then what we do is this is very simply now. We'd have some sort of decision which is represented by a diamond. So depending upon the operator, we then do the calculation. So if the operator is a plus, for example, the process would be A plus B. If the operator is I'm doing this very roughly and quickly here, so I do excuse me. If the operator is a minus, we would the process would be A minus B. The processes are in rectangles. And then finally we just, we do the same for multiply and divide, and then finally we would print the result. The other feature of these flowcharts as well is we show the way that the flow between got the arrow the wrong way around there. Okay. I'd need to edit this a bit, but you can see basically what we'd have is arrows joining these up. Okay. I won't put them all in now. Let me just delete this one. We join each component up like so. Okay, you get the idea. Oops. Okay. So the idea with this one is we start at the top, we move down to there'll be an arrow pointing down there. Get the numbers from the user as an input, work out which operator it is. So if it's a plus sign, we add. If it's not a plus sign, okay, we go down to this one. If it's not a minus sign, we go down to multiply. If it's not a multiplication, and in code, if we're implementing this, of course, the get two numbers would be an input statement. The checking the operators would be an if statement. So if it's plus, add. If it's minus, subtract. And then finally print the result. So print some sort of print statement, and then the program terminates. Do excuse how messy this diagram is, but hopefully from this you get the basic idea of how you would design the program that we're going to execute. Okay, so just to illustrate then, we would have an arrow which is the flow of control, which connects the different shapes. The input output is a parallelogram, the process or the calculation is a rectangle, and then the decisions, like the if statements, are the diamond shapes. And there's an example. This is a better example than the one I drew. So you can see the lozenges start and end, start and stop. Input the temperature in Fahrenheit. Do a calculation to convert it to Celsius. Display the answer in Celsius. If there's another temperature to calculate, loop back to the beginning and do the whole thing again. If there's no more to calculate, then end the program. Okay. If you want to have a go, try have a go at writing a program that allows the user to enter their name and calls a function to display a welcome message. Write a program that allows the user to enter two numbers and then uses those if statements or function to call functions that add, subtract, multiply and divide. If you want to stretch yourself a bit further, go onto the W3 Schools website and look at lambda functions and have a go at using some of those arbitrary functions as well. Okay. So that's it for this video. Just a reminder of the links then. So we've been looking at tutorials from the W3 Schools website, download from python.org, so you can execute Python programs on your computer, and the IDE we've been using, the integrated development environment, is phony.org. Okay, and that one we've just used there to design the flowchart is creately.com. Okay, that's the end of the skills builder. So we've covered quite a lot really in 3 sessions, to be honest with you. We've gone all the way from creating a variable, printing some text on the screen, to looking at lists, collections, if statements, loops and functions. So there's one more video which I'll explain what is required for you to enter the competition. So that's it from me today. Thank you very much for your time, and hopefully we'll see you very soon.